Hello everyone, welcome to this virtual show on the Czech eID virus. It's a talk in which we would like to present the security flaw in the Czech eID card system that potentially allow malware campaign to occur, which would steal the government-issued identities, electronic identities of the Czech citizens. So first bit about ourselves. My name is Martin Pozděna. I have been for a few years in cybersecurity. I studied first at the Czech Technical University where I met with Honza, and after that I continued my studies at the TU Berlin and University of Trento in Italy. I did change a few technical roles during my career, but at the moment I am leading a Prague pen testing team at Auxilium Cybersecurity, and if I should describe myself, I'm not a big fan of a statement, "It is secure, trust us." So this is one of the motivations behind this security research, or why we started this security research. And what I would like to add as well is that we did the security research as part of our hobby, so it was not done as part of our work. So now to Honza.
Yeah, thanks Martin. My name is Jan Řečínský. I have been working in cybersecurity for 5 years. Currently, I am working as a CSOC manager at Prague Airport. Also, at my free time, I am pen tester and co-founder of a company Vardensec, which is mainly focused to pen testing and security consulting. Now, Martin, start our presentation.
Okay, thank you. Let's start with an outline, what we would like to cover in the presentation. We would like to start with the responsible disclosure and how we reported this issue to the authorities and how they reacted. We will then introduce you to the Czech eID card system, which might not be familiar, especially to those of you who are from abroad. We will describe a legitimate login attempt, how it looks like, and then, based on that, we will explain the theory behind our attack. After that, we will show you the proof of concept implementation that demonstrate that this attack is not only theoretical, but practical indeed. And after that, we will show you the video with a demo, how this attack works. And lastly, we would like to discuss some implications and potential countermeasures against this attack. So first, the responsible disclosure. We started the security research thanks to the hackathon eObčanka that occurred in Paralelní in January 2019. eObčanka is basically just a Czech name for the Czech eID card, and Paralelní is a non-governmental think tank based in Prague. The main idea behind the hackathon was to open source the technology which comes as a black box and to see how it works. Our main motivation behind that was that someone in the past requested the public keys from this eObčanka to be publicly released or made available. And this request was rejected by the people operating eObčanka with an explanation that such a release of the public keys would undermine the security of the system, which to us as a security researchers sounded as an immediate red flag. During the hackathon, we came up with an idea, a theoretical idea about the attack, and it took us then a few months to research it, to prepare the proof of concept code, write a paper about it. And in August 2019, we reported this issue to NÚKIB, which is a national cybersecurity agency of the Czech Republic. It took just 1 week, after which we were conducted back with an inquiry whether we prefer the broker disclosure or not. The broker disclosure in this case meant that they would keep us in the loop with a discussion with all the different stakeholders around eObčanka, or another option being that they basically take it over and they will not inform us, they will not contact us anymore. We confirmed that we prefer to be named and we prefer the broker disclosure, upon which there was no response. We followed it up, and in September 2019 we received, let's say, at best a very unfriendly call from NÚKIB that was trying to persuade us into the non-broker disclosure, so that we are basically removed from the loop. We rejected that, and the day after we were followed up with a more constructive call, but then nothing was happening. In November 2019, we made a status inquiry to NÚKIB on the status. We were informed that there is no movement, and in spring 2020, we realized, or we figured out, that the first countermeasures were applied, but no one noticed us. And on 27th August 2020, we shared those slides with NUKIP, mentioning that this will go public. And at this point, this issue is publicly disclosed. And in regards to the slides being shared, we again received no response. So now let's look into the Czech eID card system and how it works. It's currently in the version 2.0 since July 2018. And in this version, it basically has two main functionalities. The first is identification against e-government services through the single sign-on solutions. So the eObčanka is basically a single sign-on that any government agency can use online to prove the identities of the people logging into their systems. It is not implemented by all the government bodies, but at the moment it's being used by the social insurance, tax office, e-prescription, certain municipalities, and so on. So this is the main functionality that our attack basically exploits. The other functionality is the creation of the qualified digital signatures, for which you need to buy separate qualified certificate. I'm just mentioning it for the completeness, but it will not be covered anymore in this talk. So now let's have a look how the legitimate login attempt looks like. Yeah, so let us assume we would like to log in to the Czech social insurance system, to the e-portal of the Social Security, and we select the login with a eID. We are redirected to the single sign-on website, which is on the left-hand side, this so-called eIdentita, or National Identity Authority. And this website then opens a dedicated application, which is called eObčanka Identifikace, which is on the right-hand side, which then takes care of all the communication between the smart card, the backend. It requests the PIN from the smart card and everything. So now, looking through the whole procedure, we have a diagram explaining which steps needs to be taken. So on the laptop side, there is a citizen's laptop. So this is myself, or Honza, or anyone else who would like to log in against the e-portal of the Czech Social Securities, which is on the right top side. And then, furthermore, there is a single sign-on front end and back end. It's heavily simplified, but for the purpose of the presentation, it is sufficient. And then on the left bottom side, there is a program, eObčanka Identifikace, which does part of the identification. So let us assume we would like to log in to the Social Security e-portal. So the first thing we do, we navigate to their website. As a citizen, I select that I would like to log in with the National Identity Authority, which is a single sign-on, and I get immediately redirected to the National Identity Authority website, which is a single sign-on website. Once this happens, the National Identity Authority generates the identification ID or authentication ID and sends it back to the browser. So this happens in step number 3. Once the browser receives that, it opens an URL through which it starts the program eObčanka Identifikace with given unique identifier from the National Identity Authority. So it happens in step 4. And at this point, the eObčanka Identifikace program takes care of all the further communication. So it starts to communicate with the backend, and it securely authenticates citizen against this backend. It uses the smart card, asks for the PIN, and does everything pretty much securely. Yeah, so this is the legitimate login attempt. I'm sorry, I forgot to mention that at the end, of course, of the step number 5, the user's or citizen's identity is tied to the unique identifier that was generated in step number 3. And because all the servers on the right-hand side communicate together, the e-portal Social Security now knows that I logged in as Martin Pozdena. So now, okay, this is how it looks. Some of you might already have an idea on how to attack it, so let's plan the attack. The idea behind this attack is basically that a chain is only as strong as its weakest link. And in this case, this is the link between the browser and the program eObčanka Identifikace. So the browser tries to open an URL through which it opens this program. You can see it on the window above, which we printed out thanks to the script we wrote. It basically tries to open the URL CZE EOP out, and then the ID MWID, which is an ID of the transaction, which you can then also see inside the program. Now looking at this, the link between the browser and desktop is only this one URL. It's not encrypted, it's not protected, it's not validated in any way, shape or form. So the question is, what happens if anyone changes such a URL? So now looking to the naive try, if we just put this URL with a QuBIT in it, the program starts and says the installation is invalid or the broken installation. So, yeah, but now what if someone tries to modify it in a bit more smart way? What if you swap two valid transaction IDs? What happens then with the authentication? So now let's look about the theoretical attack that we thought about based on the hackathon we went through. So the beginning of the authentication is the same. You go to the e-portal of the social insurance, you are redirected to the single sign-on, you get back the unique identifier that identifies your authentication session, and the browser then tries to open the program eObčanka Identifikace. But now let's assume that a citizen's laptop is infected with a simple virus that intercepts this call. And we also have an attacker's backend. So now what can happen, theoretically, is that the program eObčanka Identifikace is started, and at that point, the virus triggers and reports to the attacker's backend that there is an infected computer that tries to log in. When attacker's backend receives a call, it communicates to the single sign-on frontend in the real time, so it requests the own ID for an attacker. And there is no reason for this single sign-on frontend to reject such a request because it could be a valid authentication coming from that IP. So it generates a new session ID to the attacker, and the attacker then takes that ID and sends it back to the virus. Now what the virus does is that it swaps those two IDs in the memory, so the program eObčanka is in fact started with an ID of an attacker. So now, because this eObčanka Identifikace has no way to figure out that anything wrong happened, it again communicates to the backend, asks the user for the PIN, communicates with an user ID card, and basically authenticates the citizen's identity against that attacker's ID. The consequence of that is that the attacker at the end is actually successfully authenticated towards the single sign-on. So the attacker can now log into any portal in the name of the user. You might ask what happens with the citizen session or citizen's ID. So the citizen's authentication attempt basically times out. But there is no reason, there is no way for you to figure out why it happened. It's an unconclusive or inconclusive error or warning saying that it timed out. So most likely anyone would try to authenticate again. So theory should work, right? So how can you do it in practice? How hard would it be to implement such a thing? You basically need just two components. The first one is a virus to swap the IDs in the memory, and the second one is the attacker's backend that in the real time exchange those IDs. Although it might not sound so easy to implement, as it turned out, it was not so very hard. Yeah? So to start this attack is not so complex. So first, we need to think on how we can swap the IDs in the memory. We just did the simplest way for the purpose of the POC. So we saw that the actual eObčanka Identifikace is bundled with its own OpenSSL library. And OpenSSL, being open source, means that we can add any virus to it, compile it, and bundle it with an application. So let's replace the OpenSSL. The C developers among you would know that the OpenSSL must be initialized when the program starts or before the first use. So let us bundle additional feature into that initialization. So basically there is an if clause that's highlighted. It says that if our virus is not yet initialized, call the function spoof MWID. So the spoof MWID, what it does is basically it looks on the stack for the transaction ID and replaces it with the one that's taken from the attacker's backend through the HTTP request. So that's all from my side. I will now hand over to Honza, who will cover the attacker's backend. Thank you.
Thanks, Martin. Let's start a little bit more practical. Attacker backend is written in Python. The main function of the backend is request new MWV ID from citizen portal, providing spoofed MWV ID via REST API. Also, backend is able to complete login to citizen portal and after that harvest information from the citizen portal. What if I told you it just works? Let's look at it. On this video, on the right side, we see the malicious client and the portal of the citizen portal. On the left side, we see the console, the logs from the attacker backend. Now start the video, and on the right side, we see the citizen portal. The victim clicked to the sign in and open our malicious application with spoofed MWV ID. This spoofed MWV ID we are able to see on the left side of the screen. It's the same on the right side because the application is using our spoofed MWV ID. Now the victim enter the PIN and the backend is waiting for the token validation. Yeah. The victim click to the OK and the backend continue with function. Backend now we can see the backend log into the portal. It is a finish authentication and also authentication success. And now we can see the backend harvest the information about the victim. It's in the main, the second name, the date of and place of birth. Yeah, this is very private information we are able to get from the portal. What's the real world implication of our exploit? The first one is acting like citizen in virtual space. Nowadays, we are able with our exploit harvest citizen private information from the portal like Czech Social Security, citizen portal, airport restriction or medical insurance. These information are very sensitive for citizens and not able to get to some public. With this exploit we are able to harvest this information. Also in the future we are able to exploit or get some information about victim tax refund or maybe in very far future with the exploit we will able to manipulate the elections, the online elections. Yeah, the whole time we are talking about the exploit and how you use it. And what's about some countermeasures? The first one, which we think is able to do, is tie MWV ID to eObčanka ID number. The second one is edit some second factor to authentication, for example SMS. The third is we should be some anomaly detection, for example validation logs, detection session stealing, detected multiple login attempts from single IP and so on. Maybe some SSL lib signing or more. The last one in countermeasures is show MWV ID in browser. It's already implemented by Minister of Interior. On this slide we can see on the left side the ID and on the right side the client, the eObčanka client. If we use the exploit, these ID should be different, will be different. and it's for the victim the right state how to check if we are using the exploit or it's in the safe login to the portal. Thanks for your attention, or do you have any question? Thanks.